Hello friends, myself Dr. Nandakumar Raubale from College of Engineering Ambazogai is going to deal with fluid mechanics. In previous class we have seen hydrostatic forces on surface, definition of total pressure, definition of center of pressure, then cases of submerged surfaces, and in that we have discussed about vertical plane surface submerged in the liquid and some numericals on the vertical surface. So today we are going to discuss the horizontal plane surface submerged in liquid and numericals on vertical surface. Then the derivation for the total pressure and center of pressure on a inclined plane surface submerged in a liquid. So now very first we will discuss a numerical on a vertical plane submerged in a liquid. So this is a problem numerical. So in this numerical, a circular plane of 3 meter diameter. So diameter is 3 meter in a vertical side of a tank. So there is one tank and to which there is a hole. So closed by a circular disc of 3 meter. So in a tank there is a hole of 3 meter diameter, and that hole is closed by a plate or circular disc of 3 meter diameter, which can rotate about its horizontal diameter. Say here this is the circular plane which is going to close the circular hole having 3 meter diameter, but this is having hinge at its diameter, and this can rotate about a this hinge in the horizontal direction. So this circular plate can rotate about its horizontal diameter. It is hinged at its diameter. So he is asking us to find out force on the disc. So how much force is acting on this disc, that is total pressure, and the torque required to maintain the disc in vertical position. So here force F is going to act at point P and G is above it. So G is at the center. So when this force is acting on this plate, so this plate is about to rotate. So we must apply some force or pressure in opposite direction or torque in opposite direction to avoid rotation of this circular plate about its diameter. So how much is the torque required to maintain this circular disc in vertical position? Then he is going to say that the head of water above horizontal diameter is 4 meter. So here we will see this diagram. This is a tank and it has got a circular hole of diameter 3 meter. This is a side view and this is a front view. So this is center, and this disc is free to rotate about this horizontal diameter. Let the point P is the point at which the total pressure acts or force acts, which is below center of gravity. So distance of center of gravity from free surface is h bar, whereas distance of center of pressure from free surface is h star. So now what is given in the problem is diameter of disc is 3 meter and center of gravity of this disc. So from this point G, distance of free surface is h bar, which is 4 meter, is given. Then he is asking us to find out total pressure or force, how much of total pressure is acting on this circular disc, and where is the center of pressure, that is h star, distance of P from free surface of liquid, and then torque to maintain this plate in vertical position. What happens? This liquid is going to exert force F at point P, and because of this force, this plate starts to rotate about the center of gravity. So as this starts to rotate about center of gravity, that is nothing but the torque starts to act. So in opposite direction we have to apply the torque. So force into this distance between G and P is the torque. So torque is equal to force into radius. So radius means distance between G and P is the radius. So that is nothing but torque. So equal and opposite torque has to be applied so that this vertical plate will remain in vertical position. So to find out force, F is equal to rho G A H bar, is the equation that we have seen. So in this equation we know h bar which is 4 meter. Area of circle we can find out. G is acceleration due to gravity, rho is density. So everything is known. We can find out force. But to find out h star, the distance of center of pressure, we know Ig divided by A h bar plus of h bar. So h bar is known, area we can calculate, h bar is known. So we have to find out Ig, that is moment of inertia about center of gravity, about the diameter passing through center of gravity. So Ig is equal to pi by 64 d to the power of 4. Diameter is known. So Ig we can calculate. Ig can be substituted. Area we can calculate. Area is equal to pi by 4 d square. Then torque is equal to force into radius, as I told you. So force into radius. So what is a radius? It is the distance between center of gravity and the center of pressure. So this distance we have to calculate. So if we know h star from free surface and h bar, so h star minus h bar gives us r. So by knowing r we can find out torque, force and radius. If we know, then we can find out torque. Now we will start to simplify this problem. So very first we can find out area of disk. Area of disk is equal to pi by 4 d square. Pi by 4, d is the diameter of disk, this is 3 square. So therefore the diameter of area of this disk is 7.0685 meter square. So as we know that area is known to us, so we can find out Ig. So if we know Ig, then we can find out F and H star. So Ig is equal to Ig, moment of inertia about the diameter passing through center of gravity. Ig is equal to pi by 64 d to the power of 4. Pi divided by 64 into d is 3 to the power of 4, which is equal to just a minute, we will find out this Ig. Pi divided by 64 into 3 to the power of 4. This is 3.97 meter to the power of 4. So this is Ig we know. Now force is equal to force, or that is known as total pressure, which is equal to, formula is here, rho g a h bar. Rho g a h bar. So rho is nothing but 1000, because here this tank contains water. So here the term water is given somewhere here. Even if water is given here, so water means density for water is 1000 kg per meter cube into G 9.81 meter per second square into area which we have obtained is 7.0685 into h bar. H bar is 4 meter. Therefore force we get as 277,368 Newton, or this can be taken as 277.368 kilonewton is the total pressure or force F. Now to find out the center of pressure, H star is equal to, we know formula, that is Ig divided by Ah bar plus of H bar. We know Ig, that is 3.97. Area is known, 7.0685 into H bar is 4 plus of 4. So we can get H star as 4.14 meter. So now we know H star, we know F, we know H star, we know H bar. So to know R is nothing but H star minus H bar. So torque is equal to force into H star minus of H bar. The force is known, that is 277,368 into H star. Value of H star is 4.14 minus of H bar is 4. So this torque is equal to, we get 38831 Newton meter. This much of torque in opposite direction torque of 38,831 Newton meter in opposite direction is required to maintain the disc in vertical position. Coming to the next plane, a horizontal plane which is submerged in a liquid, where center of gravity and center of pressure are going to coincide at a distance of H bar and H star. So both are going to be at the same distance because plane is horizontal as shown in the figure. So where A is the total area of surface, then G is the center of gravity, then P is the center of pressure as we have seen, H is the distance of strip. Here if we take a strip, so distance of strip is also at a distance of H meter from the free surface. So everything is at the distance of H meter. So H bar, distance of center of gravity of area from free surface of liquid, and H star is the distance of center of pressure from free surface of liquid. So here what we can understand is H bar is equal to H star. So this surface is horizontal, therefore all are at the same distance from free surface. So therefore the force acting over this horizontal surface in a liquid, submerged in a liquid, can be given by the equation rho g A H bar or H. As we have seen for the vertical plane, the intensity of pressure over this surface P is equal to rho gh, and the area of surface, we know area of surface is equal to A. Therefore force on the surface, therefore the total force or total pressure, this is nothing but force, is equal to area into pressure or pressure intensity. Therefore we can write this A into rho g H, or we can call this as rho G A H, or we can write this as a rho G A H bar, because H is equal to H bar. So force F is equal to rho G A H bar, which is same as the previous case in Newton. Now we'll simplify one problem on this. Let us consider a tank as shown in figure. So figure shows a tank full of water. So the term water indicates us that the density rho must be equal to 1000 kg per meter cube. The total pressure on the find the total pressure on the bottom of tank and weight of water in the tank. Then hydrostatic paradox between above results. What is hydrostatic paradox? So it is the difference of pressure, total pressure, and weight of water in the tank. So both are different. So the difference is known as a hydrostatic paradox between above results. So width of tank is 2 meters. So this tank is like this. So this kind of tank is there. Now this section has got 0.4 meter thickness. This distance is 3 meter. And this is 0.6 meter. Whereas this is 4 meter. And width of tank is 2 meters. So this distance is 2 meter. This width is given as 2 meter, which cannot be shown in this front view. We can see this width of 2 meter in side view. So now to simplify this, what is required? So width B is given as 2 meter, density of water is 1000 kg. We have to find out force exerted at the bottom of tank and weight acting at the bottom of tank. So to find out force, so tank base is a horizontal surface submerged in a liquid. So we use rho G A H bar equation. So we know rho, we know G, area can be known. So area of this base surface can be known as 4 into 2 meters. So as already we have seen, so if we invert this tank, this kind of base we can find. Base of the tank can be like this. So this surface is the base, which has got this distance as 4 meter and this distance as 2 meter. 4 meter by 2 meter. Area can be obtained. So area is 4 into 2. H bar is the distance of this free surface of liquid from base. So this total distance is H bar. So H bar can be obtained. Then weight is equal to rho G into volume of this tank. So volume of this tank can be split into two parts. So total volume of this tank can be obtained by knowing the base volume. So this is the base. Volume of this base can be obtained, and over which there is a rectangular part. This vertical strip, volume of vertical strip. So let us consider, so volume of this one is V1, volume of this one is V2. So volume of base of this tank, so this is volume V1, is nothing but area into H1. So H1 is the height of this base, that is 0.6, into area of this is here, into H1 H2. H2 is 3 meter. So we can find out volume, we can substitute this volume in this, and we can get weight. So to simplify this, first of all, H bar, this total distance, can be called as H bar because the base of tank is at the distance of H bar, and which is equal to 3 plus of 0.6, that is 3.6 meters is H bar. Force is before finding force, area of base is nothing but 4 meter into 2 meter. As I told you, this has got the base area that is 2 meter by 4 meter. When we invert this tank, so base can be seen as a rectangle. So this rectangle area is 4 meter by 2 meter. So this 4 meter by 2 meter is 8 meters is the base area. So now to find out force, F is equal to rho G A H bar. So rho value is 1000 because already he is saying that the tank contains water. There's water in the tank. Therefore, density of water is 1000 into G is 9.81 meter per second square. Area is 8 meter into H bar is 3.6. Therefore, we can get this force as 282528 Newton, or that is 282.528 kilonewton. So this is force. Now to find out weight of this tank, we must find out volume. Volume of tank is equal to volume 1 plus volume 2. So base volume is V1 and upper volume is V2. So base volume is nothing but area 1 into height 1 plus of area 2 into height 2. So this base, if we consider this is the base which has got dimensions as 4 meter, 2 meter by 0.6 meter. So area is equal to, area 1 is equal to 4 into 2 into H1 is 0.6 plus of area 2. So above this there is another attachment, this part which is placed above it. So this is 2 meter, this is 0.4 meter, and this is 3 meter. So now area is 0.4 into 2 into H is 3. So this volume we can calculate as 8 into 0.6 plus 0.4 into 6, 7.2 meter cube. So total weight is equal to rho G V. Rho is 1000 into 9.81 into 7.2. So this volume into 9.81 into 1000. So this is 70,632 Newton is the weight. So now the weight is different and force is going to be different. So force F is equal to 2,82,528, whereas force is 70,632. therefore there is a difference. So hydrostatic paradox is the difference between the total pressure and weight. So we can write here hydrostatic paradox is equal to F minus W. F is 2,82,528 minus 70,632. 2,82,528 minus 70,632. So this is 2,11,896 Newton is hydrostatic paradox. So this difference between the total pressure and the self weight of water acting at the base are going to be different, and the difference between these two is known as the hydrostatic paradox. So now coming to this next bit, that is the inclined surface submerged in a liquid. So here we consider one inclined surface. So this is the inclined surface, front view of inclined surface, and this is auxiliary view. So this is the auxiliary view. This is the auxiliary view of a plane surface. So this is auxiliary view. Now when this surface is submerged in this liquid, and this is the free surface of liquid, so when we extend this surface, it meets with the free surface and makes angle theta. So theta be the angle made by the inclined plane with the free surface of liquid. Now we consider this free inclined surface in the submerged in a liquid. Now let us say that G is the center of gravity and P is the center of pressure. We consider small area dA on this strip of small area dA, and this is at a distance of h meters from free surface. So h is the vertical distance, whereas center of gravity is here. So center of gravity on this plane is here, G, so which is at distance h bar from free surface, and this point is P, which is center of pressure, or which is at distance of h star from free surface of liquid. So h star, h bar and h are the distances measured in vertical direction, whereas when we extend this plane and where it intersects to the free surface, let us call this point as O, and if we draw a perpendicular line from point O to the line intersecting at surface, when we extend this plane and intersects with the free surface of liquid, from that point we draw one perpendicular line OO. So let OO be one reference line. So now the distance of center of gravity from this reference line OO is y bar, whereas distance of center of pressure from this inclined line OO is y star. So now the distance of this strip from this reference line OO is y, say y bar and y star, corresponding to h bar and h star. So h bar and h star are vertical distances, whereas y bar and y star are the inclined distances measured parallel to the surface of plane up to the reference line OO, where dy is the thickness of this strip, and that area of this strip is given by dA. So now we'll see this A be the total area of inclined surface, whereas h dash is the distance of center of gravity of the area from free surface, h star is the distance of center of pressure from free surface, and h is the distance of strip from free surface. So these distances are measured in vertical direction. Then theta is the angle made by plane of surface with the free surface. Then G is the center of gravity. Where P is the center of pressure and dA is the area of strip. Then y bar is the distance of center of gravity of inclined surface and measured along the plane of surface. So this is the inclined distance, whereas y star is distance of center of pressure from free surface or from OO, datum line OO. Then y is also, y must be written. What is y? Y is the distance of strip from OO. So now let us discuss about the center of pressure and total pressure. So now what we have seen is the pressure intensity. Pressure intensity on the strip area. So we have considered one small strip, and on this small area, if we see pressure intensity P is equal to rho G H, because this is at a distance of H from this free surface. So this vertical distance is called as a H distance. So we call this as equation number 1. So this is a pressure intensity. So the force acting on this small area, pressure force, on strip is given by dF, and this dF is nothing but pressure P into area of strip, that is nothing but area of strip. P is nothing but a rho G H. Pressure intensity is rho G H into area of strip is given by dA. So this is nothing but dF, small force dF. Now the total pressure on whole area, the total pressure on whole area. So this dF is the force acting on this small area only. So if we want to find out complete force on this complete area, then we have to integrate. Then we get total force F is equal to integration of dF, that is nothing but integration of rho G H dA. Now from this figure what we can see is there will be a triangle. So here this is a triangle. So we will have a triangle with angle theta. Now say this is point P. This distance we call as a H star. If this is point G, this distance we call as a H bar. And if this is the strip here, so this distance we call as a H. So this inclined distance is known as Y. And this inclined distance is known as Y bar. Whereas this inclined distance is known as Y star. So if we find out sine theta in all these three triangles, say for example triangle A B O, C D O, then P Q O. So in these three triangles, sine theta is equal to H by Y, which is equal to H bar divided by Y bar, is equal to H star divided by y star. So we call this as equation. So this is equation number 2 and this is equation number 3. So now we can write this from this equation as h is equal to y sine theta. So we call this as equation number 4. So h is equal to y sine theta. Substituting h is equal to y sine theta in equation number 2, we get this equation number 2 as f is equal to integration rho g. In place of h we substitute y sine theta dA. So now here what we can do is rho g sine theta we take outside this integration because these are constants. Angle is fixed, sine theta is constant, g is also a constant, rho is also constant. So therefore f is equal to rho g sine theta integration y dA we can write. So this we call as equation number 5. So now from this equation number 5 we can write here integration y dA. So integration y dA means moment of this small area about this axis OO is the moment of this small area. So if we take integration of this complete area, so that a small area becomes complete area, full area, dA becomes A, whereas the center of this complete area is at point G, which is at distance of y bar. So this can be written as small dA becomes complete area A, whereas y becomes the distance of center of gravity of this complete area from this free surface, from the axis O. So this distance is y bar. So A y bar. So therefore force F is equal to rho g sine theta A y bar we can write. So this can be written again as rho g y bar sine theta into A. Y bar sine theta from this equation 3, y bar sine theta is equal to h bar. We can write from this equation 3, from equation 3 we can write, so here h bar divided by y bar is equal to sine theta, that is nothing but h bar is equal to y bar sine theta. Therefore this force F is equal to rho g A. In place of y bar sine theta we can write as h bar. So this equation gives us the total pressure or force. Equation number 6 gives us total pressure, force F. So now to find out the center of pressure, we can write this small force dF. So pressure force on strip of area dA is dF is equal to, as we have seen in this equation, say this is equation 1, or we call this as 1A, equation 1A. So rho GH dA. Rho G H dA. So this H can be written as rho G y sine theta dA. So small force dF is equal to this, we can write. Then the moment of force dF, so moment of this force, moment of force about this OO. So when force acting here, so this force, if we take moment about this line or the reference line OO, dF about axis OO, that is nothing but dF into y. So here dF can be taken as rho g y sine theta dA. So we call this as equation number 7. So this is equation number 7. So dF we have taken. So y can be written as or we can write as y itself as it is. So this can be written as moment is equal to rho g y square sine theta dA. So this is moment. We call this as equation number, say, 8. So this is equation number 8. And sum of all such moments. So this is the moment of small area. If we divide this complete area into small strips, so to find out total moment, we have to integrate this equation. So integrating equation, above equation, or sum of moments of all such forces. Sum of moments of all such forces. Forces about axis OO or reference line OO. We can integrate this above equation 8, that is rho g y square sine theta dA. So here rho g and sine theta are constant, therefore rho g sine theta is taken as a constant, and integration of y square dA. So integration of y square dA, y is nothing but distance of this strip from this axis O, and whereas dA is the area. So second moment is nothing but moment of inertia. So here we can write like this. So integration y square dA is nothing but moment of area or moment of surface about OO, that is represented by IO. So therefore we can write this as rho g sine theta into IO. So this we write as equation number 9. Now we can say that moment of total force F about the OO is given by, so this is the moment of small force. So here we are integrating, and then we are going to get sum of moment of all small forces by equation number 9. So we have small forces on all the strips. So moment of all forces about the axis O is obtained by equation number 9. So the force F is the total pressure force. So if we take the moment of this force about this axis O, then the moment of this force about the axis must be equal to the sum of moment of small forces about the axis. So the moment of total force total force F about OO, that is given by force F into Y star, where F is acting at point P. So distance of point P from this axis OO is Y star. So that is given by equation number 10. So equating equation number 9 and 10, we get so here equating equation 9 and equation 10, we get equation 9 is this one, 9, this is 10. So F into Y star is equal to rho G sin theta I naught. Rho G sin theta I naught. Therefore, this can be written as Y star is equal to rho G sin theta I naught divided by EF. So now we can write this as as we know, by sin theta is equal to H by Y is equal to H bar divided by Y bar is equal to H star divided by Y star. So we can take this Y star is equal to H star divided by sin theta. So in place of Y star we can write H star divided by sin theta. And in place of force F, we know F is equal to rho G A H bar. So substituting these values in this equation, say equation number 11, we are going to get. Again, one more thing we know, that is I naught is equal to, from parallel axis theorem, Ig plus of A Y bar square, where Y bar is the distance of center of gravity from this axis O. So substituting these things in equation 11, so substituting one, that is A Y star, then B value of F, and C value of I naught. So we get this, in place of Y star we can write as H star divided by sin theta, which is equal to rho G sin theta. In place of I naught we can write Ig plus of A Y bar square divided by this value of F is rho G A H bar. So here rho G gets cancelled. So H star is equal to, this sin theta is transferred on right hand side. So sin square theta Ig plus of A Y bar square divided by A H bar. So now we can take this Y bar square. Now we call this as equation number 12. So H bar divided by Y bar is equal to sin theta, or Y bar is equal to h bar divided by sin theta. So simplifying this, in place of y bar square, we can substitute h bar divided by sin theta. So sin square theta Ig plus of a, in place of y bar square we can write h bar divided by sin theta, h bar square divided by sin square theta whole divided by a h bar. So if we take this sin square theta in this bracket, we can write Ig sin square theta plus of sin square theta in denominator, sin square theta in numerator gets cancelled. So we get a h bar square whole divided by a h bar. So again, just now we got h star is equal to Ig sin square theta plus of a h bar square whole divided by a h bar. So this can be written as Ig divided by a h bar sin square theta plus of a gets cancelled, h bar gets cancelled, only h bar is going to remain. So h star is equal to Ig sin square theta divided by a h bar plus of h bar. So this is the center of pressure. So this equation gives us center of total pressure or center of pressure. So this vertical distance of center of pressure is h star, which is given by this equation for the inclined surface submerged in a liquid. So if we substitute theta is equal to 90, if this plane becomes vertical, for vertical plane theta is equal to 90, if theta is equal to 90, this sin square theta becomes 1. Therefore the equation becomes h star is equal to Ig divided by a h bar plus of h bar, as because sin 90 is equal to 1. So again, when this plane becomes vertical, the value of theta is going to be 90 degree. At that time, same derivation or same equation which we have derived for a vertical plane, we are going to get in this case also. So this is a most generalized equation which can be used for horizontal or for inclined or for vertical plane. So we stop here, and in next class we will be simplifying few numericals on this inclined plane surface submerged in the liquid, and then afterwards we'll start with the curved surface submerged in a liquid. Thank you.